Okay, for number 5, probably the toughest question here. By the way, this was not an easy problem set, by the way. Like, I think they're really kind of all tricky problems at this stage, all right? Number 5 is consider the sequence AN, given where AN is equal to the arctangent of the secant of AN, and they have a seed value of pi over 6. Find the value of a positive integer m that satisfies, boy, this is complicated. So what I want to do, I want to kind of write down what they're saying. And you just, all you can do is maybe go one step at a time and something like this over here. So I'm looking at the problem itself. And what do I do know? I know that AN plus 1 is equal to the arctan of the secant of AN. I do know they give me a seed value, A1. I'm not sure how important that is, but pi over 6. All right, we'll get back to that later. But what I know about this over here, the secant of pi over 6 is certainly going to return a positive number. All right, pi over 6, and the arctan is going to be between 0 and pi over 2. All right, so what I'm going to do over here is, just think it's going to be maybe easier to write it, writing that the tangent of AN plus 1 is going to be the same thing as the secant of AN. And again, if we're starting with 1, we're going to get a positive number, and that's going to be a positive number, all right? So I'm going to say they're equal. I don't have much issue with that. Now, thinking about it, I'm going to say the numbers are going to behave nicely. And what I'm going to do, I'm going to square both sides now. So I'm going to square both sides, say tangent squared. There's a point to this, because I know a relationship between tan and secant, but there's a Pythagorean relationship between their squares. Again, there's a Pythagorean relationship between their squares. And again, I'm trying to get this into a simple pattern problem. And I'm looking at secant, or just remind you that sine squared of theta plus cosine squared theta is equal to 1. And you could divide both sides by cosine squared. You get tangent squared theta plus 1 equals secant squared theta. So I think I can write this down now. So tangent squared theta, which is AN plus 1, is going to be, let's see, the secant is going to be tangent squared. And again, I'm looking at the right side now. So it's going to be tangent squared AN plus 1. All right, I just took this and rewrote in terms of tangents. And then I got to start thinking about, does this help me at all? And I think it does. And I want to start off with the seed value. All right, and start off with what they said. And what they said, and I got to read it back over here, given something, the seed value is pi over 6, find a positive integer m, and this is where I got to start thinking now. And I got to be clear about it too. Well, let me write this down now. And I'm going to, just start by saying tangent squared of A2 would equal tangent squared A1 plus 1. All right, I'm going to write down tangent. Again, we're using this to generate a sequence now. A3 would equal tangent squared A2 plus 1. Well, I know what that's equal to, and that's going to be this guy over here plus 1. So it's going to be 2 plus tangent squared A1. All right? The only thing I did over there is I want to go back to the A1 because I'm looking for a pattern. So tangent squared A4 would equal, again, we're using this up here, is going to be tangent squared A3 plus 1. Well, A3 is this guy up here, so I get 3 plus tangent squared A1, right? All right, I got to keep going though. And so why you keep going? It's going to keep going and going and going and going. But I see there's a pattern over here. And let me write this down for you. I'm going to say the tangent squared of AN, looking at this pattern by the way, is going to be N minus 1. Again, that's 4, that's 3, that's 3, that's 2, that's 2, that's 1, so forth and so on, by the way, plus tangent squared A1. All right? I got a problem, by the way. So what's the problem, by the way? I'm looking at this tangent squared A1, and again, I want to go back to that seed value. And the seed value, I got to remind myself, A1 is going to be, I got to look at it, is pi over 6. And that's going to be 30 degrees. All right, so I'm going to put my triangle down. That's 30 degrees. That'll be 1, that's 2, that's root 3. So what's this really equal to? It's n minus 1 plus the tangent, which is 1 over root 3 squared, so 1/3. All right, so write this down. Tangent squared an is equal to, and I'm getting a simpler expression, by the way. You come down with 3, and you get 3n minus 3 plus 1, which is going to give me 3n minus 2 over 3. All right, so I got something simpler now. At least I know what the tangent squared is. And by the way, if I know tangent squared, I probably could figure out secant squared at this point. But the deal is about this. I didn't ask that. All right, so why'd you get that? I'm looking at this equation they're giving me. So they're giving me 1 over 1/100th is equal to the sine of A1 times the sine of A2 times, I'm going to say yada, yada, yada. Now, I see the pattern. It's a multiplication problem, by the way. And they're going up to n. So, whoops, I don't think I should put that down. Let me erase it. Up to am now. I did it again. It's the sine of am. All right, I need to get that sine in terms of tangents and secants, by the way. And let me write this over here. So the sine of theta is the same thing as the tangent of theta over the secant of theta. Let me just go through that with you. Tangent sine theta over cosine theta, and secant theta is 1 over cosine theta. They cancel off and you get sine theta, all right? So I'm going to rewrite this guy in terms of tans and secants. And I'll write that down, hoping something nice happens. And you're going to get the tangent of A1 over the secant of A1 times the tangent of A2 over the secant of A2 times, I think you get the idea, yada, yada, yada. Eventually we're going to get to this tangent AM over tangent, not tangent, what am I keep doing that, don't I? Over the secant AM. All right, I got to remind myself looking back over this thing over here. And initially what I had was I had the tangent, right, this over here, 1/100th. The tangent, I have a relationship over here, and the relationship is going to be this over here. an plus 1 is equal to arctan of secant an, which means the tangent of an plus 1 is certainly related to the secant of an. All right? So let's see if we can put that down. So think about that too, don't I? So I'll put down a tan of A1. And I'm looking at this now, and the secant of A1 would be the tangent of A2. I just did this factor in the problem. Let's do the next one. The tan of A2, and again, I'm looking at this over here. It's important that the secant of A2 would be the tan of A3. I think I'm seeing the pattern. Next one would be tan of A3 over the tan of A4. I'm going to yada, 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 put this last guy down, which could be tangent of AM, and this will be the tangent of AM plus 1. Now, what I know about this over here, that there are a lot of cancellations. This cancels, this cancels, this cancels. And by the way, there'd be something here canceling this, and everything else in between cancels off. So I get this over here. 1/100th is equal to, and I gotta be careful now, the tan of A1 over the tangent of AM plus 1. Well, I'm getting close. And the question is, do I remember what the tangent of A1 is? And I do. It's up here. It's going to be 1 over root 3. So I put this over here. This top is 1 over root 3. Now, do I know what the tangent of AM plus 1 is? Well, sort of. I have something over here, relationship. I'll write this down for you. I know the tangent squared of AN is equal to 3n minus 2 over 3. So therefore, I know that the tangent squared of AM plus 1 is going to be 3 times m plus 1 minus 2 over 3. And what do you get there? You get 3m plus 3 minus 2 is plus 1 over 3. And that's tangent squared, by the way. And again, what do you get over here? You get the root. So you get the root of this thing over here, which is 3m plus 1 over 3, 1/100th. Well, I got to simplify this because it doesn't look right to me. This is 1 over root 3. I'm going to multiply by the bottom's reciprocal, which would be root 3 over the square root of 3m plus 1. These cancel off, and you get the root of 3m plus 1 equals 100. I'm going to square both sides, and you get 3m plus 1, 100 squared. Then I'm going to subtract 1 from both sides, and you get 9,999. Then I'm going to divide both sides by 3, and you get m equals 3, 3, 3, 3. Remarkable. I think that was their question. I want to go back and read it. And it says, consider the sequence, find the value of positive integer m. We did do that. It's 3,333, and we're done. Thank you.